Hey everyone, welcome back to the channel. This is Expert Funda and you're watching on YouTube. So the question is saying that we have a distinct points reachable after substring removal. So this is the third question from the contest 166. Okay. So the question is saying that you are given a string S and it consists of character U means up, D means down, L means left, and R means right. So these are the characters are consist. Okay, it represents representing the moves on the infinite 2D Cartesian grid. You know the Cartesian plane, right? And that is a grid. We can say that it can move in up, left, right, means all the four directions. You can say that. This is what we have in the example, as you can see, right? We'll discuss in detail, so don't worry. So what it is saying, if you are going up, you will move from the current point. If your current point is x and y, you will move into the y Cartesian plane, right? That we know that. Similarly for the D, I hope you understanding these things, right? How we are moving up, down, and left, right? So at very first, the problem looks weird, right? You are walking on a grid, you have to delete some moves, right? And suddenly you are asked about the distinct final position. But the trick is here that the solution is not about simulating the thousands of path. It's about understanding pattern and using sliding window approach, right? So it is saying you are also given integer k, as you can see here. So you must choose and remove exactly one contiguous substring of length k from the string s. Then we will start from the coordinate 0 0 and will perform the remaining moves in order. So we should return an integer that is denoting the number of distinct final coordinates which is reachable, right? So what is the trick is here? So solution is not asking about thousands of path, right? So it's about understanding the pattern where we will use the sliding window that you can understood from here, right? So let's grab your notebook and try to understand. Okay, so let's go here. Okay, let me check my pen. Okay, I hope you are able to see. Okay, yeah. So problem number is it was 3694. Okay, the problem is saying that what is saying, distinct points reachable, right? That is, it is saying reachable after substring removal. Try to understand the problem. Okay, so very first I will suggest take your notebook and try to understand, because there is many approaches that I want to talk about this problem, but let's try to see. Okay, so if I'll say what the problem is saying, that means, let's suppose you are standing at, this is your infinite 2D Cartesian plane, this is your y axis and this is your x axis. So if we'll talk about this position, I think okay, so this is, it should be a straight, but let me clean it here. It's fine to write like that, but somebody will say you this is not the straight line. Okay, so let's little straight I will do. Okay, this is your x and this is your y, correct? So if we'll talk about, if you are standing at here, so this point is nothing but what? This is your 0 0, both x and y both are 0 0. So if we'll take this side, this become your left and this become your right. If you come down, it become negative y, right? Means this is minus x, we can say, and this is your minus y. This is the Cartesian plane. So let's suppose you are standing at here, right? This is your nothing but a 2D grid, you can say. So you have a string of moves. Let's call u means up, there is a d for down, left and right, correct? So before you actually start walking, you are forced to delete some exactly one continuous block of length, that is called k, it was saying, right, from the string, right? You have to do what? You have to delete. Okay, what is this delete? A contiguous block, you can say, right? What? Contiguous block, we can say that, right? Exactly one contiguous block. Okay, then you walk according to the remaining moves, right? One of the remaining moves. So the question is, after choosing which substring to remove and how different the final coordinates are possible. This is important because we are not counting how many ways to reach the coordinates, right? There are many possibilities. So we are only counting distinct final. It should be distinct and final positions after all the deletion. What? After all the deletion. Understanding or not? If you're understanding, then fine, right? Means what we are going to do, we are not counting how many ways to reach a coordinate, right? Any positions we can say. Let's suppose for this point you are standing at here, so there can be many possibilities, right? Because we have to delete some blocks of the strings, and then we have to find it, right? So we are not counting the distinct, we are not counting so many things, but we are only counting the distinct final positions after all the deletions, and then we'll check the we'll count the things, right? Let's understand the example. Okay, so very first, the example 1 was given is string s, and it contains L, U, L, and K is 1. This is what we have given. So okay, let's draw this string as nothing but L, U, L, right? If you say L, U, L, okay, if I remove the first L, okay, then the path is UL, right? So very first we remove L, right? First L, then the path is UL, right? And at the end we'll say is nothing but -1 and 1. Why? Because left we have removed, right? And we are at initially at 0, 0, right? So if you will remove the left, we can say, so we'll say okay, from U and L we'll move to the first end, and that is nothing but what? -1 and 1, correct? Then we'll say okay, now you remove the another U and L left, so remove this L, right? So the path length again become what? From L to 1, and it end at where? At -2, and this becomes 0, correct? Similarly, if we will remove this L again, last L, because there is only one left, so the path will become what? We say the path is L, right? And it goes from U to I, and it ends at where? -1, -1 again, sorry, -1 and 1 again, right? So the distinct, if you see here, is nothing but what? 2 minus -2, 0. So this is, and we are getting what? Another value we are getting what? -1 and -1. So for this case we'll say distinct is -1 and -2, 0. This is to distinct point we have, because this is a duplicate, we can say that, right? So notice how some removal gave the same endpoints, right? We only count unique ones, because here we already counted one points. If you see again, you will get again the same points, right? This is making sense, right? I hope you are making the sense, right? If it makes you some sense, right, let's try to understand another example. We had u, d, l and r, okay, and we'll take k equal to 4. So here we must remove the whole string since k is how many? 4. So if we'll remove all of them, right, no more left here, right? So it is a final, and the final is nothing but 0 0. You are at the position where you are there because we have removed all. So answer will give is 1. Only 1 is 0 0, right? Let's try to see another example. We have a string u, we can say u, right, and k is nothing but is 1. So very first we'll remove this one, remove the first u, and the path will become is what? The path is from u to u is at 0 0, will go to 0 1, correct? Then we'll remove again another one and we'll say the path will become what? Again u to 0 1, but this is also duplicate, so we'll return this only one path and we'll say distinct is nothing but 1. This is distinct, okay, this is distinct, and we'll return only 1. Okay, I hope you understand. Okay, so now let's step back. What is the pattern? What is the pattern here? What is the pattern here? So instead of simulating every possible path, you have to notice that every substring has a net vector that is called dx and dy. If you have seen the daily contest video in today morning, right, you have seen this one, right? So this is called net vector. This net vector is, we can say, is nothing but how many steps right minus left and up minus down. Keep it in the notebook, keep it in your notebook. Okay, so can we say that, okay, to find the final endpoints, can we say that after a removal, we can say the substring is what? We'll say, okay, what is total vector of entire string? Can we say that? We'll do minus. We'll do minus what? The vector of a removed substring. Okay, you check the substring. Okay, this is what we have to find for the final endpoints. That's it. We don't need to simulate every path. We only care about these substring vectors. So the problem is reduced now. What it is reduced now? We'll say problem is count how many distinct is was dx dy we are talking about, right? Pairs are there, right, that appears among all length minus k substring, right? Can we say that? Now this is our problem and it has been reduced. Can we say that? So how do we do this efficiently, right? There is a naive approach. You could compute the vector of every substring by scanning k moves each time, that will give you O of n into k, which is way too slow for n up to 1 lakh, we can say, right? With 10 to the power 5, we can say that. Okay, so instead we use a sliding window, right? Let's understand it. Sliding window. Very first we'll compute the net vector, okay, for the first window of k size, correct? Then we'll say, okay, then slide the window one step at a time, right? So when we are going to do that, you have to do two things. First, add the effect of new incoming move, right? And second, we can say you subtract the effect of outgoing move. And then in step 3, we'll say, okay, each time you store this dx and dy in a set, or you can say in a hash set, right? Because using Java. Then in the last, at the end, the size, we have to set the size in our answer. Can we say that? We can do that, right? And so let's go to the code, then you will understand. Okay, other than, if you don't want to do that, you can use the prefix sum also, where you can compute the prefix for x and y both, and each time you will find the vector, each vector will find the difference of the prefix, that will give you the O of n time. Okay, otherwise you can use the brute force approach, but that will not work. And you can use the rolling hash also, where each moves have to do into the hash and then you can roll it, right? So I'll talk about this into the live class tomorrow morning. Sorry, I'll not discuss here on the Leetcode, sorry, on the YouTube. So I'll discuss in the class. Okay. Let's try to recap what are the things we need to do. So very first, we will use the sliding window here. We'll compute the net vector for the first window of size k. Then we'll slide the window of step one step at a time, and we'll add the effect of a new incoming move. Then we'll subtract the effect of outgoing moves, and each time we'll store dx and dy in the hash set, and at the end we'll set the size in our answer. This is what we need to do, right? Understand what we need to do? So let's recap. Means we can say the trick was realizing a final endpoints equal to the total vector minus substring, what do you call, substring vector. It means we only need a distinct vector. That is why we use the sliding window here, right? So let's calculate all the substring vector in O of n times, we can say that. Okay, and the hash set will handle the uniqueness, and the answer is just in the answer we have to set the size, right? So let's try to understand through the code that we can understand. Okay, let's go to the console here, and we'll try to implement the very concise code. So very first, we know that we have given what the distinct points we have given. right? And for that we have given a string. String we have given means we have given all the moves we have given, and the k we have given means how many removals we have to do in this, right? So let's try to understand here what we need to do here. Okay, so very first we'll find the length, that is nothing but our n, and then we'll find the dx and dy for the vector, right? We'll create a helper function, right, just to apply the moves. Okay, and we'll pass the sign here. Then we'll use a lambda expression where we'll get the move, delta move we'll get, and from the delta move we can get the dx and dy. We will use this. Okay, and then we will use a HashSet, and HashSet will apply, we will use the pact, we can say, and we'll create a separate function, and we'll use dx and dy. Okay, this is what we need to do. I think we have read it here. Okay, so this pact will, what this pact will do, as you can see, this is, we are passing the in the pact x and y. So it packs to we can say 232-bit bit sign of x and y into a single 64-bit long. So you can store a pair in a HashSet because the HashSet will take in the long, right? So we'll use into one as you can say as a map key, we can say, without creating a new object, because if you want to create a new object, right, we have to create a class and those things. So better than you can use a concise code. You will just compact this code and we can use without creating this object. That is what we are doing here, and we are adding into as a as a key, we can say, right? So it will use as a map key. So we'll create a for loop for all the k will start at k equal to let's suppose 4, and it will go to I. Okay, so let's, or 0 you can say. So for each time we'll get the dx and dy, will keep adding in the dx and dy will update. Then we'll, because I told you two things we need to do, right? One, the adding part, and another is removal part, the subtract part. So both you will do apply here, and each time you will add onto the set, right? Then you just return the size. Okay, and this is your move delta, where you will find the character, and based on the character, if it is right side you will do 1 0, if you are left side you will do -1 0, if you are using up you will do 0 1, if you are using D down 0 -1, if you are at the same position where you have started, that is 0 0. Okay, this is what we need to implement, guys. It's not a too hard problem, it's a medium level question, but in case you are not understanding, let me know in the comment section and we can discuss more in detail. Okay, but if you want the structure way of learning, right, the preparation in the very minimal cost on monthly basis, I'll give you the 1-to-1 session, and we can start from scratch. Okay, and we'll go from 0 to hero. So all the classes are running. I'm trying to start on another batch. Either the 1-to-1 session is also fine and the batch is also fine. So please contact through the WhatsApp, and in case you have any doubt, please ping me in the comment box. Thank you guys, thank you for watching this video. I'll see you in the next one.